So just to make sure everybody is able to hear me, right? And you can see the screen I'm sharing with you. Yeah, awesome, wonderful. So we were basically towards the end of chapter 3. Of course, we talked about how to convert between the two forms of our standard equation and the transformation equation. Then last class, we got into the different properties and characteristics of a parabola, a quadratic equation. So we talked about if your parabola opens up or down, what the vertex of your parabola is, the axis of symmetry. And then, of course, we also got into talking about the domain, range, maximum, minimum value, the interval where your function is increasing, decreasing, and that's kind of, one of the main things we had talked about. And then towards the end, we also talked about how to find our x and y intercepts. And then we got into solving inequalities, and that's where we had basically stopped. So I wanted to ask you if you guys were comfortable working with solving these inequalities, both by the graphing method and the test point method. Did anybody have questions on the quadratic inequalities here? You guys feeling okay about that? Yeah. Okay, so the last part that we needed to discuss here on the word problem, yeah, Della, that's what we're getting ready to look at here. So the last part that we wanted to talk about were how to use these properties of finding, that maximum or minimum value on your parabola. So we can actually use that concept in applications such as this. So this is talking about, if we want to maximize cost or, maximize profit, or we want to get, from a given space, the maximum area. Well, how can we go about doing that? So that's where this idea of finding the maximum or minimum value of your parabola will come into play. So just to refresh your memory on that, basically, once you find the vertex of your parabola, you know that k value basically ends up becoming your maximum or minimum in this case. So remember, your vertex is going to be at h comma k. So if your parabola is opening upwards, then your k value will become the minimum on your function. If your parabola, of course, is opening downwards, then we know the k value will become your maximum value. So that's what you basically have to do in these applications is, of course, first we come up with our equation. And then once we have our equation, we try and find out what the vertex of the parabola is. And then from there, we will go ahead and, of course, try to find the maximum and minimum value. So before we look at the example from my MATLAB, let's go ahead and take a look at this example. So this is the one we'll do in my MATLAB, number 14, but number 13, let's do that here from our handout. So this one is saying Chandra wants to enclose a rectangular garden with 200 yards of fencing. What dimensions for the garden will maximize its area? So if we are talking about, a rectangular garden. So with a rectangle, of course, the two longer sides are what we call as the length. The two shorter sides are what we call as the width. Now they're telling us we have 200 yards of fencing. So that basically means if we put a fence around this yard, that total perimeter should come out to be 200 yards. So that's actually where we get started in here is try and figure out what our perimeter will look like. And then based on that, we try to calculate what the area will be. So you kind of have to use both the perimeter and area formula in this type of an example over here. So can anybody tell me for a rectangle, what is our perimeter formula just in generic terms? So when we talk about the perimeter of a rectangle, what does that formula look like? And, obviously you can just share your answer with me through chat. Oh, Della, that's actually going to be the area formula because when you do length times width. Yeah, Maria, very nice. So yeah, pretty much you end up adding both the lengths and both the widths together, right? Just add the four sides and you will have your perimeter there. Very nice, perfect. So that's exactly what we are trying to do over here. So to write it out, you can basically say the perimeter formula can be, since you have the two lengths, we add the two lengths together plus the two widths together in this case. And then of course we know our perimeter is 200 yards. So you can actually replace that and write this as 200 equals 2 times the length plus 2 times the width. So we're going to have to clean this up a little bit. So since you can see that you have that 200, which is, the 2 times the length and 2 times the width, since both of them have a 2 in common, we can actually factor out that 2 on the outside and then leave the length plus the width on the inside. So you're basically taking 2 from both of them and bringing it outside. And the reason we're doing is so we can simplify this equation a little bit. Okay, so at this point, you have 200 equals 2 times, and then in parentheses, length plus width. So I'm going to go ahead and divide both sides by 2. And as you can imagine, I will end up with 100 equals length plus width. Now, at this point, it honestly doesn't matter. You can either get the length by itself or you can get the width by itself. You just have to basically isolate one variable. So I'm just going to go ahead and subtract the W on both sides. And we will end up getting 100 minus W equals L. Okay. So what we are doing is we started out with the information that was given to us. We took the perimeter formula. We took the 200 yards of fencing that we have, and then we basically plugged it into the perimeter formula, cleaned it up, and now we're going to take this little equation that we just came up with, and we're going to use this. Oops, sorry. So we're going to take this equation, and now we are going to substitute this into the area formula. Okay, so now, and this is the formula that Della had shared with us. So the area formula, oh, I guess I went with a darker color. Oh, well, is length times width. So now that we have this guy as, length equals 100 minus W, you're actually going to use that to substitute your length over here. So we will put in the 100 minus W over here, and then that multiply by W on the outside. And the reason we are doing this, guys, is because we cannot solve the equation if you have two unknown variables in there, because we just don't have enough information to solve the area formula with two unknowns. So that's why we use the perimeter formula to kind of rewrite that formula so that we could get either length by itself or width by itself. And now we're using that to substitute into the area formula so that we can all break it down into just one single variable. And in this case, the way we rewrote L equals 100 minus W, your area formula actually will now be in terms of W. So go ahead and distribute this guy inside the parentheses. And you will see this will come out to be 100 times W. And then minus W times W will, of course, give us W squared. And this, of course, is your just general area. So this is where your perimeter, your quadratic equation is coming from, because now you will see this equation has a second degree exponent, and that gives us our quadratic equation. So this is now our quadratic equation over here. And based on this, we can now find what the vertex of our parabola is going to be. So for finding the vertex, and if you wanted to, rewrite this in the standard form, you will bring the negative w square in the front, and then the 100w will be positive. So this is, your x square in the first term, then the x term, and then your constant term, so that y equals ax squared plus bx plus c format, except, we're using area and the width of the rectangle as our variables. So once you get it down to this stage, now we can talk about finding the vertex of our parabola. So we need to find what that vertex is going to be. So for this guy, I'm going to need a little bit more space here. So remember, when your equation is given in the standard form like we have here, to find the vertex, we use x equals negative b divided by 2a. So in this case, our negative b of course is going to be the 100. Two times a, your a of course would be coming from the coefficient of the w, which of course you can see there's a negative sign, so that tells us our a value is going to be -1, right? So you end up with -100 over -2, which will of course simplify down to a 50. And you know what? Instead of actually calling it x, let's call it w, because that's what we have as our variable here. So your w actually comes out to be 50. Which means if we take this 50 and plug it back into our equation, what will our other variable come out to be? So let's open a calculator here. We've got, and I'll put it in this form here just to keep it, simple. So we've got, let's see, 100 times 50, so that's the 100 w, which will of course give us 5,000, and then from that we are subtracting w squared, which will of course be 50 squared. And you can see that's going to come out to be 25. Will that be 2,500? Yes, it will be 2,500. So remember, this is the w value, this is the area. So our maximum area that we can come up with will be 2,500, right? But the question is actually asking you what are the dimensions, which means they are actually asking you what is the length and the width. So of course we know the width is going to be 50 yards. What is the length going to be in this case, guys? And for that, you can come back to this equation here, the L equals 100 minus W. Della, yeah, perfect, very nice. So your length would be 100 minus W, which would of course be 100 minus 50, which would of course come out to be 50 yards itself. So you will notice when the length and the width are the same measurement, they are both 50 yards and 50 yards. Instead of a rectangle, what shape do we have here? So if your length and width is the same measurement, instead of a rectangle, what kind of shape do we have? Perfect, guys. So you will notice when you see examples like this in your homework also, most of the time to maximize the area from a closed, box shape, basically, instead of a rectangle, you are actually going to get better area. If you're trying to get the maximum area, is actually having a square instead of a rectangle. Okay, so that was one example of how we can use the idea of, we can use the idea of, that maximum minimum value to try and come up with our, area, in this case, the maximum area. Now, this question over here, which was number 14 in your handout, is talking about this archer shoots an arrow, and it's it's very similar. Where did I go? There we go. Very similar to this example over here. So this one is basically talking about if an archer shoots an arrow upwards with an initial velocity of 192 feet per second from a height of 7 feet, they're basically saying to find the height of this arrow as it travels above ground, based on time, which will be in seconds, can come from this equation here. And then based on that, they're asking us to find what will be the maximum height the arrow reaches and how long will it be before it, touches the ground. It comes back down to the ground. So obviously you can see from this equation, we do have a quadratic equation here, right? Because you have your t to the second power. So the t represents the time and the h represents the height. So that's kind of how this general equation is set up. So we're just looking at different numbers over here. So as you can see, this guy has, if an archer shoots an arrow straight upward with an initial velocity of 128 feet per second, the archer is standing at at a height of 9 feet, then its height above the ground in feet at time t in seconds is given by the function h of t equals negative 16t squared plus 128t plus 9. So if you imagine what this looks like, that archer is standing at a height of 9 feet. So, imagine he's standing on a platform or something, this can be your ground. So when he shoots the arrow, and, this is just my poor archer. So when he shoots the arrow, your arrow will make kind of that parabolic shape before it comes back and reaches the ground over here. So that's kind of what you are trying to figure out. So that initial velocity of 128 feet per second, you can see that's where that 128 is coming from. The height that the archer is at 9 feet, you can see that's where that 9 feet is coming from. Does anybody know where we get that negative 16 from? Because it's a falling object, right? Anything that's going to come back down to the ground, you have to take into consideration gravity, right? So that's your constant for the way the gravity force, and it's negative because your object is coming back down, right? If it was going to keep going up, that number would have been positive, but because it's bringing it back down, that's where that negative comes from. So that negative 16 is a factor from gravity. So that's kind of how you set up these equations. And you guys, if you make it to a calculus class, you will actually see examples like this, because this is a calculus-based question over here. We've of course simplified it because you didn't have to come up with the equation. You're just using the equation to find the other information here. All right, so we have our equation. Now they want to know what is the maximum height reached by the arrow. So, of course, that would be right over here. And as you can imagine, if we're talking about the maximum height, we're talking about what your vertex is going to be. So in this case, since we have t as our variable and height as the dependent variable, you can actually think of this as t comma h. So you are literally finding the vertex of this equation here. So let's take a look. Our equation is h of t equals negative 16t squared plus 128t plus 9. So again, to find the vertex, you're going to take t equals, same formula, negative b over 2a. So what are the b and a values in this example, guys? So what's our a and b value here? Yeah, Della, perfect. Very nice. So we will have, oops. B is of course going to be 128. A is going to be negative 16. So as you can imagine, that'll be negative 128 minus 32. And can you tell me what that answer comes out to be? Perfect. Very nice. Yeah, Maria and Jimena. So 128 divided by 32 will end up giving us 4. Now remember, this is the t value. So basically it's telling us it's actually going to take our arrow 4 seconds to get to the maximum height, but they are asking you what is the maximum height reached. So you take that 4 and put it back into the equation now. So this will now be h of 4. And then we go ahead and solve this as negative 16 t squared. So that becomes 4 squared plus 128 times 4 plus 9. And this will give us our maximum height, which of course will then be in feet. So let me see what you come up with for the feet. All right, looks like I've got Jimena and Della. Hey, Maria, you've got a larger answer than what I did. All right, let's see if I can plug this in here. Move it a little bit to the side. So we've got negative 16. So let's see, I don't know if you guys can see that. Maybe here. So you've got negative 16 multiplied by 4 squared, which will give us negative 256. Then to that we add 128 times 4, which will give us positive 256. And then to that we add the 9. So you should have 2. Yeah, very nice, Maria. Glad you figured that out. So yeah, you should have positive 265 as your feet over here. So this will be, our maximum height reached. So let's go ahead and put that in. And let's check that answer. That looks good. Now they want to know how long will it take the arrow to reach the ground. So this will not be the 4 seconds, obviously, because the 4 seconds takes us to get to the maximum height. So what you have to do now to think about that second part is when it reaches the ground, which means we want to know when it hits the ground over here on the right. So what's your height going to be when you reach the ground? What's the height of the arrow going to be? Very nice, Diego. I see your hands. So perfect. So when your arrow reaches the ground, that means your height is going to be at 0 feet, right? Because that's your ground level. So that's actually what we need to do for part B. So, think of this as part A. Now, part B, you're actually going to take your height and set it equal to 0. So this will then become negative 16t squared plus 128t plus 9. And then instead of h of t, you're replacing that with a 0. So that's what we're going to have here. So for this guy, I would recommend using the quadratic formula to solve this, because you don't want to mess around with, factoring and all of that, I think the quadratic formula will work the best in this case. So that would be t equals negative b plus or minus square root, and then inside you have b squared minus 4ac. Divide the whole thing by 2a. So negative, and then our b value was 128, and you can see I have that here in the green marked all of them. So negative 128 plus or minus. Again, inside the square root, you have b squared. So 128 squared minus 4 times a is negative 16, c is 9, and then divide the whole thing by 2 times a, which would be negative 16 again. So let's see how we can clean this guy up. I am going to go ahead and erase some of this other stuff here. Okay, so clean up what you can, and then, of course, we will need to simplify this. So just taking it from here, kind of bringing it back over here. So we've got negative 128 on the outside, plus or minus. When we take 128 squared, of course, you can expect a large number for that guy. And that one is coming out to be 16384, right? 16,384. Now, for the other part of it, you're basically, what I'm going to do is treat this negative, the minus 4 as a negative, and we need to multiply the 4ac. So I'm just going to think of that negative and make that into a positive. So that will then end up giving us positive here, and then we can multiply 4 times 16 times 9. All right, Della, I see your answer. So just go ahead and multiply the 4 times 16 times 9. The negative and negative will become positive, and so you will end up getting 576 from that. And then, of course, on the denominator where you have 2 times negative 16, that will, of course, become negative 32. So now you have negative 128 on the outside. Let's see, what can we do with the inside? I'm kind of hoping it will be a nice clean number that we can take a square root of, but we'll have to figure that out. So this guy is adding up to, looks like 16,960. And then we still have negative 32 on the denominator. Does that square root come out to be a nice clean answer? Doesn't look like it, does it? 16,960 is not a perfect square, and I can show you that over here. Ah, there you are. So if we tried to do 16,960 and take its square root, you will see we get a decimal answer. So that's telling us this is not going to be a nice and clean number. So then I'm not going to worry about simplifying this since it doesn't come out, as a perfect square. So now we just need to know what time it's going to take for the arrow to reach the ground. So you will definitely come up with 2 answers from here because you have negative 128 plus or minus. So let's break it down into plus first, plus the square root of 16,960 divided by negative 32, or we have negative 128 minus the square root of 16,960 divided by negative 32. So we are going to have 2 different answers, and we just have to see which one of them is going to be a better answer to work out with, right? Because not both the answers are going to be valid in this case. Okay, so let's see what this guy will give us. Kind of trying to navigate it so it's not hidden by all my writing, but that doesn't seem to be working out. Okay, so we'll start with the 16,960, take its square root first, and I'm going to leave that as a positive number. So from that, I'm going to go ahead and subtract my 128, which will give us this. And then when you divide it by 32, we would have to make sure that it's negative 32. And you can see this is what that answer will come out to be. So the positive square root of 16,960 will end up giving us negative 0.0697, which, again, this should be time, and time cannot really be in a negative number. And obviously, this is showing a very small value over here. So this is not going to work out in this case. So let's see what the other side gives us. So again, we've got 16,960 that we take a square root of, but this now has to be a negative number. From that, then you are subtracting the negative 128. So from this, I'll subtract 128. And you can see this is what we come up with, negative 258 and some change. Divide this by, again, negative 32. That was our denominator. And you can see this guy ends up giving us actually an answer that will work for us. So you are now getting, for this guy, positive 8.0697, seconds. So that's kind of how you have to decide between the two. So the negative answer is definitely not going to work for us. It's got to be this guy. And then they're asking us to round it to 2 decimal places. So that's exactly what we're going to do. So this guy will become 8.069. So 2 decimal places would be 8.07. Does that make sense, guys? Why we couldn't use the first answer? Because when you're talking about time, obviously time cannot be negative, so that automatically gets discarded. So that only leaves us with the second option where you got the positive 8 point something as your answer there. So let's go ahead and check this guy. Make sure we did everything correctly. And yeah, that looks good. So that's kind of how you have to break down this part 1 and part 2 on this. Della, did it accept your answer if you left it as an equation? Oh, you're on mute, sorry. Because I am wondering, since they tell you to round your answer to 2 decimal places, if you leave it just as a simplified equation, it may not accept that answer. Okay. Yeah, so like I said, because this is that square root of 16,960 is not going to simplify. You will not be able to get down to an integer answer, so you are going to have to do a decimal approximation on this. Did anybody else have questions on this example here, guys? All right, let's go ahead and clear this out then. And let's take a look at the next one. So this is actually kind of the example that we did with, the rectangular garden before. So you can see this one is talking about a rectangular playground is fenced off and divided in by 2 by another fence parallel to one side of the playground. So this one, what they're talking about is basically you have a rectangular playground. So if you have a rectangular playground and then they're telling you it's fenced off and divided in two by another fence. So what that means is, you're kind of just something like this. You're dividing it in, smaller parts also. So dividing it in two by another fence parallel to one side of the parallelogram. So something like this. 240 feet of fencing is used. Find the dimensions to maximize the enclosed area. So as you can imagine, this is very similar to this example we did over here. The only difference is going to be we didn't divide this in the center, right? Like we are doing over here. So the only difference you're going to have here is now, when you talk about the perimeter, we're going to have the longer sides. So our length, so you still have two lengths, but now you are actually going to have three widths. So instead of two widths, you will have three widths, and then they're telling you you have 240 feet of fencing, so that becomes your perimeter. So 240 feet of fencing will be twice the length plus 3 times the width. So in this case, when you try to simplify it, it's going to be a little bit different because, let's say we start by subtracting 2 times the length on both sides. You will end up with 240 minus 2 times the length, and then 3W. Then we will go ahead and divide everything by 3. So of course, 24 goes into 3 evenly. So 240 will also go into 3, and this will end up giving us 80 minus 2/3 the length equals W. So again, in our example, we don't also have to worry about fractions, but that's the same thing we did. We got one variable by itself. So we got the length by itself, and we moved the width to the other side. And then, we were able to substitute that into our area formula. You're going to do the same thing here. You've got your W equals 80 minus 2/3 the length. And now you can come back and put it into the area formula, which is length times width. Since this guy is set up for the width, we're going to substitute for the W over here. So that will end up giving us length times. That's just the clock in my living room, guys. Sorry about that. So we've got length, which will stay as it is in this example, and then you'll substitute in for the W, which will now be the 80 minus 2/3 length, right? So bring that in, just like we did in the previous example. Go ahead and distribute this outside length inside the parentheses, and you will end up getting 80 times L minus 2/3, and then L times L will, of course, give us our L square. And as you can imagine, that's our quadratic equation now. So we can now find the vertex and see what our two numbers come out to be. So again, to find the vertex, we will use negative b over 2a. Now, in this example, guys, the square is still going to be your leading term. So this becomes our a. Just the L by itself with no square is your middle term. So this becomes your b. So be careful about that. So negative b over 2 times a. So our b was 80. A was negative 2/3. And we'll need to clean this up. So negative 80. If it helps, you can put a 1 underneath the 2. So this will become negative 2 times 2, which is negative 4. 3 times 1 will be obviously 3. We had talked about this in chapter 1, probably even in chapter 2. When you're dividing by a fraction, remember you can change the division to multiplication and then just flip your fraction around. So you can do negative 80 multiplied by negative 3/4, and that'll give you your answer. So let's take a look at what this guy comes out to be. Okay, so we're taking 80 which is a negative number, multiplying it by 3, dividing it by 4, which is also a negative number. And you can see that'll come out to be a positive 60. This was in feet, right? Yeah, 60 feet. So your length will come out to be 60 feet. And, of course, if you put it back into the equation, that will tell you what your maximum area will come out to be. So in that case, we have, let's see, 80 times our length, which is 60. From that, we are subtracting, and I'm going to put my 2/3 in parentheses just to be sure. 2/3 multiplied by length squared, which would be 60 squared. And you can see our maximum area will come out to be 2,400 square feet. But just like the example in our handout, they're actually asking you for the dimensions and not for what the maximum area is. So we already know our length is going to be 60 feet from here. And then we just have to calculate our width. And for the width, you can obviously do the 80 minus 2/3 L. And in that case, your L is 60. So can you tell me what our width will come out to be? And in this case, you are not going to end up with a square because we separated the playground into, 2 halves. This one doesn't convert into a square like we did with the handout example. So does anybody know what our width will come out to be? And of course, that will also be in feet. Okay, Maria, I've got, looks like 40 feet from you. All righty. Very nice. So basically, as you can see, and I move this guy here. So you would end up doing 80 minus, and then again in parentheses, I'll do the 2/3 and then multiply the 2/3 by our 60 feet. And you will see that comes out to be 40 feet for our width in this case. So that's of course going to be your shorter dimension, and then your larger one is going to be the 60 feet for the length. So these are the two answers we are looking for. Okay, so let's type our numbers in. So the smaller dimension is 40 feet. Let's check that answer. And then our larger dimension is going to be 60. Questions, guys, on this example here? Okay, all righty. So let's clear this out. All right, so that's pretty much what our last part of section 3.1 is talking about. All right, guys, let's get into our next section. And this is where we're kind of building up and getting more into our polynomials. Okay, so remember, when we're talking about zeros of polynomials, we're basically talking about finding the root or finding the solution, or in other words, finding the x-intercept for these polynomials. So let's look at this example over the first theorem over here. Now, just to kind of remind you guys, when we're talking about polynomials, something like a linear equation is also a polynomial, which is a degree 1 polynomial. A quadratic equation is also a polynomial. It's a degree 2. So you can go degree 1, degree 2, degree 3, degree 4, as high as you want those exponents to go. So you can have like x to the 5th, x to the 7th, x to the 9th, those kind of polynomials also. So the idea is we just want to give you basic skills on how you can try and find solutions for some of these higher degree polynomials. So again, remember, when we are talking about finding the zero for a polynomial, you are basically taking your polynomial equation, setting it equal to 0, and then whatever solutions you end up finding, those would be what we would call as the zeros of the polynomial. So if you look at an equation like this, p of x is equal to x squared minus 9. When we go ahead and solve that equation, set it equal to 0, solve it, you are going to end up getting the two answers, which would be positive 3 and negative 3. So, we can use factoring to solve this. We can use the square root property to solve this because it's a quadratic equation. You can use any of those methods to solve this guy here. So 3 and negative 3 end up becoming the zeros of these polynomials. And you can see in the graph over here, that basically ends up becoming where your graph is crossing the x-axis at, right? So your x-intercepts. So that's what your zeros are. Your zeros are your solutions. They are your x-intercepts. And they are also the roots. They are all the same thing. Okay? So we're basically looking at, okay, so how can we use this technique to find for some of the other types of polynomials over here? And they kind of go into that same description, they can be the x-coordinates of your x-intercepts, so on and so forth. So they are basically saying if you have a polynomial which is of degree 2 or less, you can find your zeros basically by solving the quadratic equation or the linear equation. But what do we end up doing if it's a higher degree polynomial? So we're going to have to break this down. It's not always as straightforward as solving the quadratic or the linear equation. So sometimes we have to kind of narrow down our options, and that's what you're going to be learning here in the next couple sections. So let's start out with our remainder theorem. This one is basically saying that if you take your polynomial and divide it by, this factor of x minus c, then basically you should get the answer of r equals p evaluated at that value of c. So basically, let's think about this. So we're talking about finding or using the remainder theorem to find, what the p of 1 answer will come out to be. So in this case, since they're giving you p of 1, which is kind of in this format here, we're going to set it up as x minus 1. And we're going to have to divide our polynomial by this factor of x minus 1. So this is actually where, guys, we're going to bring back something that you probably haven't done in a while, and that's going to be long division. So we're going to try to have to see how we can use long division to simplify this. So this x minus 1 is what we're dividing it by. And then your polynomial, of course, is x squared minus 7x plus 9. And you know what? Let me write this out a little bit better because I'm going to run out of space like this. Okay. So we're going to take our p of 1 and we're going to set it up as x minus 1. Then we're going to take the x minus 1 and divide it into our polynomial of x squared minus 7x plus 9. So let's take this slowly because, like I said, you probably haven't done long division in a while, and I'd imagine you haven't done it involving polynomials in a while either. So you have x squared over here, and you have to try and match that. And, think about these in terms of numbers. If you had 2 over here, and you had, I don't know, 7 over here, we would try to get as close to 7 as possible. So we would say, okay, 2 times 3 gives me 6. I'll take the 6, subtract it into 7, and I'll get a remainder. So how can we get close to x squared in this case? So of course, since I have a single x in my divisor over here, I just need one more x in my quotient. So when I multiply, I will get x times x, which will give me x squared. Then I will multiply my -1 with the x also. So -1 times x will give me -x. And then I'm going to subtract this from my dividend. So all we did here was we took this x from our x minus 1, and we said, okay, to make that into an x squared, we need another x, and that's the x we put here on the top. So now we take the x minus 1 and multiply it with this x. So x times x gives us x squared, minus 1 times x gives us -1, and then you are subtracting this. Now remember, when you are subtracting, your signs will change. So you will need to distribute this. So this guy will technically become, -x squared, and this guy will end up becoming positive x because you distribute that negative sign inside the parentheses. So don't want to mess this up too much. So basically you just have to think about, when you distribute this sign, this guy becomes negative. When you distribute this sign, this guy becomes positive. So now that we have one negative x squared and one positive x squared, they will end up canceling each other out. So positive x squared here, this guy became negative x squared, they cancel out. Now you have -7x and a positive x. So -7x and a positive x, of course, will end up giving you -6x over here. So remember, -7x, positive x will give us -6x, and then you just bring down that +9 at the end because we have done absolutely nothing with it so far. Question at this point, guys? Okay, if you don't have a question. Now, again, we are still not done because we can simplify this further. So again, looking at my dividend over here where you have the x minus 1, I have x over there. So this x is already taken care of, but now I need the -6 also. So that's exactly what we're going to do to turn this x minus 1, this x over here into -6. We'll put a -6 up here so that we can multiply our x with -6. So then when you multiply x with -6, you get -6x over here. Then we take the -1, multiply it with -6. So -1 times -6, negative and negative positive, you will end up getting +6 over here. Now, again, we need to subtract this guy because that's always what you do with long division. So same thing's going to happen here. You take this negative sign and you distribute it inside your parentheses. So negative times negative, this will now become positive. Negative times positive, this guy will become negative. Okay, so now, as we did before, you have a -6x here. This guy became +6x, so they cancel out. And then you have a +9 and a -6, so we can go ahead and subtract those. So +9 and -6 will, of course, then end up giving us 3 as our remainder. So this guy here, this is our quotient. This is, of course, our remainder. And this one is what we call as divisor. And then your x squared minus 7x plus 9 is what we call as the dividend, because that's the number that's being divided. And you will actually see this terminology later on also. So this is how the remainder theorem works out, guys. You're supposed to do your long division to try and see what the answer will come out to be. Now, to check that you did this correctly, and I'm going to get rid of this guy here. Okay, why is it not letting me erase it? There we go. Let's get rid of this. To check our answer, We will now take our P of 1 and put it inside the polynomial. So you have x squared minus 7x. So 7 times 1 plus 9. So that will, of course, become 1 squared minus 7 plus 9. And what do you think this answer comes out to be when we simplify these three numbers? 1 minus 7 plus 9. Yeah, Maria, perfect. Very good. So 1 minus 7, of course, gives us -6. -6 plus 9 will give us 3. And you will see this is going to be the same as the remainder you got over here. And this is what they were talking about in the statement up here, where they said if you take the P of C and you put it into your polynomial, it ends up giving you the remainder as your answer. And you can see you have now looked at the long division. When we did that math, we got 3 as our remainder, and that's the same 3 you get when you just plug in that value into your polynomial. So this is what the remainder theorem does. And like I said, they kind of break that down over here. But I know long division can kind of be a little intimidating if that's something you haven't done in a long time. And I've included that over here on the left-hand side so you guys can kind of see how that breakdown works out to be. And I'll talk about synthetic division in a minute, but before we get into the synthetic division part, I want to make sure nobody has questions on this guy here. Okay, if you don't have any questions, then let's take a look at this example from my math lab. So it's the same thing you just did. So the reason we distribute the negative is because we do, in the traditional way of long division, you are always subtracting the new numbers that you brought in over here. So whenever you bring in like this guy over here, you have to subtract that. And because we have, two terms, because you have the x squared and the x term, you have to distribute that negative sign into both of them. Because if you just had x squared minus x and you try and subtract that, if you don't distribute it, then you're only putting the subtraction on the x squared. You wouldn't transfer it to the second term. So to be able to transfer it to the second term, we do have to distribute it. That's the same thing that's happening over here. You had -6x plus 6, and you're taking that whole thing and subtracting it from this expression here. So again, the same thing we have to do is go ahead and distribute, because otherwise that negative would only apply to the first term and not to the second term, and that would be incorrect. So in this case, you will end up distributing that negative sign. Maria, does that make sense? Because that is what we got from, hold on a second. That is what we got from, so at this stage here, you had -6x plus 9 left behind. So when we simplified this guy, we got -6, and then we just brought the plus 9 down. Now to get rid of this -6x, we multiplied a -6 to the top in our quotient. So then you multiplied x times -6, which gave you the -6x. You multiplied -1 times -6, which gave you the +6. And then when we subtracted this, this guy ended up becoming +6x. This guy ended up becoming -6x. And then we could go ahead and cancel these two out. We could go ahead and add these two, which is where we got the 3 form. So whenever you are working with long division, this is kind of what it breaks down into. Let's take a look here at just a general example. So I'll go back to my numbers. You had 2, and let's use, I'm trying to see if I can do, I don't know, let's do 27. So if you want to try and get close to 27, we would have to see, okay, 2 times what number will get me as close to 27 as possible? And the answer would be 26. So that would be 2 times 13, which gets us to 26. So once you find that answer, you always end up subtracting, which would then end up giving you 1. You can have something like 3 dividing into, I don't know, 19. Yeah, so when you get 3 into something like 19, we would say, okay, again, what is the closest number I can get to? And that would be 18. So that would be 3 times 6 gives us 18. And again, you end up subtracting it and then you get a remainder. So that's kind of the process that you normally do with long division. Now we're just transferring this over to polynomial. So let's take a look at this example and we're going to try and do the same thing here. So this guy is telling us using ordinary division means using long division. So that's what your textbook calls is ordinary division. Use ordinary division of polynomials to find the quotient and the remainder when you divide the first polynomial by the second polynomial. So this is your first polynomial. This is your second polynomial. So you're basically going to be doing w minus 3, divide that into negative 4 w to the third power plus 4 w to the second power minus 7. So you can see we have the w over here. So since we have w here and this is w to the third power, what do you think we need in our quotient over here? How many w's are we going to need so that we can match? So you have w to the third here, but only a w over here. Actually, Brenda, you need 1 less than that. Since you already have, I'm going to erase these arrows that I did. So since we have 1, because this is understood to be w to the first power, right? So you actually need to go 1 below that. So since we have 1 here, you will actually need only 2 over here. And then, of course, we also need that negative 4 because we want to cancel out that first term. So you take that negative 4, put that in your quotient. Since you have w over here, you will need 2 more w's in your quotient. So we take negative w to the fourth power. Now, remember, guys, you are multiplying. So it's w times negative 4w squared. So this will become negative 4 w to the third power. Then we're going to take the negative 3 and also multiply it with the negative 4w squared. So negative times negative will become positive. 3 times 4 will become 12. And then, of course, we have the w squared. And then again, we are subtracting this. So I'm going to put that in parentheses again and subtract. So remember, negative times negative, because you will be distributing that. Negative times negative will make this guy into a positive. Negative times positive will make this guy into a negative. So those signs will change. And that also means the negative 4w cubed and the positive 4w cubed will cancel each other out. And then we simplify the middle term. So you have positive 4w squared and negative 12w squared. So can you tell me when you add them together what you get? Positive 4 and negative 12 will give us what? Yeah, perfect. Very nice, Stephanie. And your name got hidden, Maria. Yeah, very nice, ladies. So now we would then have negative 8w squared left behind. And then, of course, bring your last term, which is negative 7 down. Okay, so repeat the process. Now you have a negative 8, which is left behind. So we'll put that negative 8 in our quotient. Now you have w squared over here, but we already have 1 w in our divisor, so you just need 1 more w over here. So again, -8 from here goes into the quotient. Since you have w squared here, but we already have one of these, you only need one more w in your quotient. So we'll go ahead and put that in. And then again, multiply. So that will now be w times -8w, which again will be -8w squared. -3 multiplied into -8w, so negative times negative, again positive. 8 times 3 is 24, and that'll become 24w. Again, you are subtracting this. So let's see. Distribute the negative sign. Negative times negative will become positive. Negative times positive will become negative. So again, like we did before, -8w squared and positive 8w squared cancel each other out. The -7 doesn't have a w on it, right? It's just a constant term by itself. So that actually means our -24w will stay as it is, and we'll bring the -7 down. So it may have actually been a good idea, and I didn't think about this before, to actually put a placeholder and just put a 0w in there to mark that missing spot, and then move the -7 at the end, because 0 times anything is 0, but then it doesn't mess up with your positioning. So that might be a better idea, to go ahead and put a 0w here and then move the -7. So that way you guys also don't get confused in subtracting the 7 with the 24w, because we can, since the 7 doesn't have a w on it. So yeah, go ahead and just insert that extra term of 0w in there, so you have a placeholder for the missing term. Questions? Okay. So as you can see, now we are left behind with, again, two terms. We have the -24w from here, and that -7 is carrying forward. So all we need now is, I already have the w over here, so I don't need another one, because this is also just w to the first power. So we have the same w, we don't need that. So all we need to add in our quotient is the -24. So just put that -24 from here into your quotient, and then we'll be ready to simplify this. So back to multiplying. W times -24 will give us -24w. -3 times -24. So negative and negative again would be positive. What is 24 times 3? Like 70 something. 72. And then again, you need to subtract that. So Della, again, since we had a -24w left behind over here, so because once we simplified this, from here, you got the -24w and you brought down the -7. So now we want to get rid of this -24w. And since you have a -24 here, that's the same -24 we use on the top. Okay, awesome. So let me get rid of these markers that I just did here. All right, guys, so we are now transferring this negative sign into the parentheses, or distributing it. So negative times negative again will make this guy into a positive. Negative times positive will make this into a negative. So again, -24w, positive 24w cancel each other out. And the very last thing you are left behind with over here is -7 minus 72. And these are both constant terms, so we can combine them together. And what kind of answer do we get over here? So -7 minus 72. Perfect. Yeah, Stephanie, Della, Maria, very nice. We will get -79 over here. Yeah, because you're just adding the numbers and keeping the negative sign. So you will get -79. And remember, this is our remainder. And this guy here is our quotient. Okay, let's plug in these numbers. So this guy would be, let's see, negative 4 w squared minus 8w minus 24. So that's the quotient. That looks good. And then remainder was, of course, negative 79. And that looks good too. Anybody have a question on this example here? So you will only have a couple questions, guys, where they'll ask you to do the long division like we did here. For most of them, you will actually be able to use synthetic division, which is going to be faster than this. It's actually conceptually the same exact math you do here, but instead of writing it out, you know, with all the W's and everything like we did in these examples, you don't have to do it quite as detailed as what this guy looks like. So let's take a look at how a synthetic division works out. So we'll go ahead and erase this guy. And yeah, this is your synthetic division. So let's move on to our handout here. And you can see this is the same example we did over here. But this is on the right-hand side is the way the synthetic division works. So what you end up doing in this case is you take your coefficients from your polynomial. So you've got x squared, which has a coefficient of 1. So that's where this 1 is coming from. Your middle term is negative 7x. So that's where the negative 7 is coming from. And then our constant term is 9. So that's where the 9 is coming from, right? So you take all of your coefficients from your polynomial. Now, of course, they were asking us to find p of 1, or we were dividing it by x minus 1. So again, guys, remember when it says x minus 1, that means 1 itself is positive. You know, if you just solve this, you will get x equals positive 1. So that's why you're dividing by 1 over here. So the way synthetic division works is you take the first number and just bring it down as it is. You do not do any math on that. And you're literally just bringing that 1 down as it is. Then you start multiplying. So then you do 1 times 1, which is where this guy comes from. So multiply these two numbers and you get 1 over here. We go ahead and subtract these. You get negative 6. Then multiply the negative 6 with 1 again. So negative 6 times 1 will give you negative 6. You subtract that and you get 3. So this last number is your remainder, which is, of course, the 3 we had here. And the 1 and the negative 6 become part of the quotient. So negative 6 is the constant term, and then this will become your x term. X minus 6 is your quotient. The other thing to remember when you're working with synthetic division, or honestly with any division, this degree on your quotient is always going to be 1 degree smaller than the polynomial you started out with. So since the polynomial we started out with was x squared, your quotient is going to be x. And you can see that right over here. The degree of your quotient is always 1 degree less than your dividend. And just remember that, and you will be able to break down your synthetic division. And you can see it's literally the same math, but it works a lot differently than what the long division looks like. So that's the reason why you will end up seeing that we use synthetic division more often than we do long division, right? So let's take an example on how to work with synthetic division here. So we'll do this guy very quickly. So as you can see, you have the x to the 3rd power over here. So we have x to the 3rd power, but x squared is missing. So we are actually going to put a placeholder for the x squared. And just like I showed you with the example before, put a 0 there. You have the minus 7x plus 5. Now in long division, if you don't put the 0 for the placeholder, it's fine, but you do have to use the 0 term in your synthetic division. You have to have that place for the missing term in there. Now, when you set this out, my coefficient on x to the third is 1, my missing term 0, then my negative 7x, so the negative 7, and our constant term was the 5. They're asking you to divide this by x plus 2. So set that equal to 0, and you can see this guy comes out to be x equals negative 2. So you will be dividing this by negative 2 over here. So, again, we kind of did this when we were talking about circles and transformations. When you see the plus sign, that automatically means 2 itself is a negative number. So, you're going with the opposite. Or do this little calculation here, and that will also tell you x equals negative 2. Now, for that first part, bring it down as it is. No math involved in that first part. Just bring down the 1, and then you start multiplying. So 1 times this little 1 over here on the bottom. 1 times negative 2 will give us negative 2. So 0 minus 2 gives you negative 2. Now multiply these two numbers together. So negative 2 multiplied by negative 2 will give us positive 4. Negative 7 plus 4 will give us what? So go ahead and add the negative 7 with the plus 4, and what will we get? Yeah, Stephanie, very nice. You get negative 3. And then again, we multiply negative 3 with negative 2. So negative 3 multiplied by negative 2 will give us positive 6. And then, of course, you end up adding them together, which will end up giving you 11. So remember that very last number is going to be the remainder. And then the remaining numbers on the left become part of the quotient. And as I showed you before, your quotient is going to be 1 degree less than your polynomial, that the dividend that you started out with. So your remainder, your quotient then ends up becoming, we started with x to the third, so this guy will be x squared minus 2x minus 3, because that's a 1, right? So the coefficient is 1, but you don't actually have to write out the 1. So you end up with x squared minus 2x, and then the minus 3, that becomes your quotient. Question about the synthetic division here, guys? Okay, if you don't have a question, then let's do this example here from my MATLAB. So this one is talking about, again, using synthetic division, find the quotient and the remainder, divide your first polynomial by the second polynomial. So again, this is our first polynomial. This is our second polynomial. So let's see, we have 2a to the third minus 3a squared plus 10a plus 6. So there are no missing terms in there. So we can do 2 from the first coefficient, negative 3 from the second one, 10 from the third one, and 6 from the last one. And then we are dividing this by a plus 1/2. So again, set that equal to 0, which tells us our a equals negative 1/2, right? And this was sort of just our scratch work on the side. So you're actually going to be dividing this by negative 1/2. So as I showed you before, again, just take that first number and bring it down as it is. You're doing no math on that. So just bring down that 2. And then now we start multiplying. So you are multiplying 2 times negative 1/2. Can you tell me what that comes out to be? Yeah, Maria, very nice. You will end up with -1 because the twos basically, cancel each other out, leaving you behind with -1. So you're going to put that -1 over here. And then, of course, we add -3 and -1. And what will that come out to be, guys? Stephanie, perfect. -4. So again, then you take -4 multiplied with that -1/2 again. And what will we get for him? +2, Maria, very nice. Stephanie, yeah. So again, you have now two negative signs in this case. So negative times negative becomes positive. 4 divided by 2 is 2. And then, of course, we're adding 10 and 12. So, 10 and 2, which gives us 12. And then, of course, you go back, multiply the 12 with -1/2 now for that last part. And what will that guy give us? Yeah, Stephanie, very nice. You will end up with -6. And then what kind of remainder do we end up with? Yeah, very nice, guys. It will be 0, right? Because 6 and -6 will end up canceling each other out, and you end up with a 0 remainder. Perfect, very nice. Alrighty, so you can see the last part becomes your remainder, and then the remaining 3 numbers will be part of the quotient. So since you again started out with a to the 3rd power, your quotient is going to be 1 degree less, so that'll be a to the 2nd power. So that's your 2a squared minus 4a, and then the plus 12. So this becomes our quotient. And then, of course, this was our remainder over here. So let's go ahead and plug these guys in. So 2a squared minus 4a. Then we had the plus 12. Perfect. And then our remainder was 0. All righty. Questions over here, guys? So do you guys think you can get the hang of synthetic division? Yeah, and you can see it does go faster than the long division, right? I mean, it doesn't take quite as long to break this down as a long division does. So I do like using, synthetic division. Like I said, there's only a couple questions which will ask you to use the ordinary division or the long division. But for most of these going forward, we're going to stick with synthetic division. Okay, if you don't have any questions on this one. Okay, so we're kind of building up on that now. So we have our synthetic division. And then this little paragraph over here is just basically talking about kind of the same thing. To find the value of your polynomial, you can take, whatever you are dividing by, whatever that number you're dividing by, and you put it into, your polynomial, the p of x. The answer you get should be, the same as your remainder. And we saw that in the remainder theorem. So that will work in these examples also where you're doing synthetic division. So that remainder theorem that we looked at obviously works for all types of polynomials. Just keep that in mind. And you will see they're telling you that using long division is not an efficient way to evaluate a polynomial. However, a synthetic division can evaluate some polynomials using fewer arithmetic operations, even than what we use in the substitution method. Honestly, the synthetic division works faster than even substituting the number into your polynomial and finding your answer. So that's kind of what they're having us do here. Again, is using synthetic division. So I'm not going to solve this. You have this in your lecture notes, but just to show you how you would set this up. So you've got the x to the third, the x squared, but you will see you have the x term missing. So when you're writing this out, you will need to do x to the third plus x squared, and then put a spot, placeholder for the x term. So the 0x, and then you can bring down your -9. So this would break down into 1, 1, 0 for the missing term, -9. And then, of course, we would end up dividing by 3 in this case. One other thing I want to point out over here, guys, when they give it to you like they did over here with the x plus 2, we did have to simplify it so that we could come up with what our x value is. But when they give it to you in this format where they said find p of 3, you don't have to do, x equals, I mean, in that case, x equals 3. You don't have to like simplify for it. So this automatically means they're telling you x equals 3, and you just use the 3 over here. You don't have to worry about changing signs. Is it positive, negative? It's whatever they give you in the parentheses. That's the same number you use for division, okay? And then you can go ahead and divide it and, get your answer. So you already have that, like I said, in your lecture notes if you want to look through that. Let's get into the factor theorem. So here's the second theorem we're looking at after the remainder. This one is saying, let's say you have a polynomial, x squared minus 6x, minus x minus 6. And, obviously our goal is to find those zeros for these polynomials. So we can factor this guy, and this factors into x minus 3, x plus 2. And as you can imagine, when I multiply -3 with +2, I get -6. When I add these two numbers, I get -1. So obviously this factoring works out. And then when you take each of these factors, set it equal to 0, you get x equals 3 and x equals -2. So remember, these would be our roots, our zeros for this polynomial, also known as solutions or the x-intercepts. So the factor theorem basically says that if you have a number c, which is a 0 of your polynomial, when you solve it, this is only possible if and only if you have your x minus c, which is also a factor of your polynomial. So they're basically saying x equals -2 can be a 0 if and only if x plus 2 is a factor. Same thing with this guy. We would say x equals 3 if and only if x minus 3 is a factor of our polynomial. So that's what the factor theorem is basically talking about. If x minus c is not a factor of your polynomial, then c cannot be a 0, is basically what they're saying if you look at it, in the other way around. So that's kind of what they're talking about here with the factor theorem over here. So that's kind of how these two guys are tied in together. So, again, when you get a 0 remainder, that's how you actually know that you have reached a factor. And that's exactly what happened in this example over here, because we had a 0 remainder. So when you get a 0 remainder, that's actually when you know you will be able to reach, you have a factor for the polynomial you're trying to break down. So that's kind of what they're talking about here. Synthetic division can be used in conjunction with your factor theorem. If your remainder, when you do the division, comes out to be a 0, then that means you have found one of your zeros, and that is going to be a factor of your polynomial also. So you have found your 0, you found your x-intercept, your root, but you've also found one of the factors for your polynomial. So let's take a look at this guy here. They're asking us to figure out if x minus 1 is a factor of this polynomial or not. So again, guys, we have the square term missing over here. So we're going to go ahead and add 0x squared in the mix. So using our synthetic division, you've got x to the third power, which has a coefficient of 1. Your x squared term is missing, so we're going to put a 0 for it. We have -3 for the x term and +2 for our constant term. We want to know if x minus 1 is a factor, so set that equal to 0. And you get x equals 1, so you're dividing by 1. Now again, bring that first number down as it is without any calculation. Then we multiply. 1 times 1 is 1. You add 0 and 1 together, bring that down, and you keep repeating that. So go ahead and finish this and tell me, are you getting a 0 remainder or not? Because if you don't get a 0 remainder, you don't have a factor. You have to get a 0 remainder for it to be a factor, okay? Okay, Della, you're getting a 0 remainder there. All right, let's take a look here. Maria, you got a 0 also. Diego, all right. Very nice, guys. So let's see. We had this one at once we added the 0 and the 1. So 1 times 1 will give us a 1 again, which will give us -2 over here. 2 times 1 is -2. Perfect. Yeah, you got a 0 remainder, which tells me, yes, x minus 1 is a factor, which also means then our 0 is x equals 1. And, of course, this guy here would give us the quotient, which would come out to be, let's see, this is x to the third power. So this guy would be x squared plus x minus 2 on our quotient. And I think that's the same example. We have something similar here. Yeah, so you will see this one is also asking us, do we have x minus 4 as a factor of our polynomial over here? So for this guy to be a factor, again, we would need to divide this. So we have 1x to the third, 6x squared, minus 19x, minus 84. So we don't have any missing terms. So no need for zeros. What are you dividing by, guys, if you're given x minus 4? +4, yeah. So take that, guys, set it equal to 0. And you get x equals 4. So we're dividing by 4. Again, go ahead and tell me, do we get a 0 remainder or not? Because if you get a 0 remainder, then of course we'll go ahead and do part A. If you don't get a 0, then of course the answer would be part B. So it really does come down to, do you get a 0 remainder or not? Okay, so Maria, you said you got a 0 remainder, but Della, you did not. Stephanie, 0 remainder. Okay, let's check this and see what happens. So 4 times 1 will give us 4. Add 6 plus 4, of course, gives us 10. And then you are multiplying 10 times 4, which will give you 40. And then what does that end up giving us? We do 40, and then you have -19. So that will give us a +21. Yeah, it looks like this should work, because then you do 21 times 4, which of course ends up giving us a +84, which will then end up giving us a 0. Oh, you subtracted instead of a multiply. Okay. Della, no worries. So this will give us a 0 remainder. And then, of course, this becomes part of our quotient. Now, there's actually two parts to this question, guys. They are asking us to figure out if we have x minus 4 as a factor, but then they are saying if it is a factor, then we have to completely factor the polynomial also. So your quotient being 1 degree smaller than your polynomial will now become x squared plus 10x plus 21. So you actually need to go ahead and factor this one more time. So from here, you get x minus 4, and then you need 2 more factors, which will be coming from this quotient. So we will do, yes, this is a factor, and we'll go ahead and type that guy in, x minus 4. But then what does our quotient break down into? What does the factor for this guy come out to be? What is this here? So 2 numbers that multiply to give us 21 and add up to give us 10. And since both of them are plus, these guys will also be plus in the factors. Yeah, perfect. Maria and Della, very nice. Yeah, 7 times 3 gives us 21. And when we add 7 and 3, we get 10. So these 3 put together become our factors for the entire polynomial over here. So we already have x minus 4 in here. Now let's go ahead and put x plus 7 and x plus 3. And that will be your factored form. So you know what I'll tell you to keep easy track of, because most of the time what I have seen happen in this example is students will remember to put the x plus 7 and x plus 3, but they forget that, you know, we actually started out with x minus 4 as the first factor we were checking for. So the only thing you should kind of remind yourself is, since this is to the 3rd power, I should have 3 parentheses in here. So that will tell you you have to have 3 factors into your answer over here. So since this is x to the 3rd power, we should have 3 different parentheses, you know, for the factors in here. I think that would be the easiest way to remember this. Questions on this one, guys? Are you feeling okay with synthetic division now? Yeah? Okay, if anybody has a question, feel free to stay back and I will answer any questions for you, but we'll stop here, guys, and then we'll pick up from section 3.2 next time. So I really do appreciate you guys for coming on Zoom and attending class with me. Hopefully I should be feeling better by Thursday and I should be on campus. But if anything changes, I'll let you know. But for now, let's plan on meeting on campus, okay? So have a wonderful day, guys. Thank you once again, and I will see you on Thursday. Have a wonderful day, everyone. Be careful. Take care. Bye, guys.